Good morning, good afternoon, and good evening, philosophers, and welcome back to Philosophy of Science through the lens of medicine. In the last episode, we looked at the stalemate between scientific realism and scientific antirealism, one side insisting that our best scientific theories tell us what the world is really like, and the other quietly asking whether we might just calm down a little bit. Today, we're going to drag that abstract debate over the philosophical coals and drop it into the middle of a modern medical mystery. Let's talk about Alzheimer's disease. From a physical standpoint, the pathology of Alzheimer's destroys the brain. It's characterized by a loss of synapses, which are the vital connections between neurons. Normally, as this physical pathology advances and synapses in the brain are destroyed, patients suffer severe clinical symptoms: profound memory loss, cognitive dysfunction, and the gradual loss of abilities that once seemed completely ordinary. You've probably all seen it in elderly people, perhaps even a loved one. But here's where the science gets very strange. Medical researchers have repeatedly observed a massive discrepancy between the physical degree of brain pathology and the clinical symptoms patients actually present. In 1989, researchers examined the brains of several elderly women after they had died. They found that many of these women had advanced, severe Alzheimer's pathology in their brains. Physically, their brains had been ravaged by the disease. Clinically, though, nothing. While they were alive, these women had shown no obvious cognitive symptoms. They had functioned perfectly normally. Their brains had been hosting a neurological disaster, while somehow the rest of them continued as if nothing much was going wrong. A bit like university department during budget cuts. We're seeing something similar with strokes. A stroke of the exact same physical magnitude can completely debilitate one patient while leaving another totally unaffected. So the question is, how on earth is this possible? To explain this disconnect between physical brain damage and clinical outcome, scientists introduced a new concept called reserve. Initially, researchers leaned on a passive model called brain reserve. This is essentially a hardware explanation. The idea is that some people simply have larger brains or a higher number of synapses, and because they start with more hardware, they can sustain more physical damage before they cross the threshold into clinical impairment, which kind of makes sense, right? Think of it like starting life with a deluxe brain package: more storage, more processing capacity, possibly still no ability to remember where you put your keys, but technically more hardware. So some of that hardware can go wrong and you can continue to function. But brain reserve just couldn't explain everything. So researchers introduced an active model called cognitive reserve. If the brain is about hardware, cognitive reserve is about the software. Cognitive reserve proposes that some individuals possess highly efficient brain networks or have an enhanced ability to recruit alternative brain networks and cognitive strategies to compensate when their primary networks are damaged. In other words, when one route through the brain is blocked, the mind doesn't just give up, lie down and wait for a committee meeting. It reroutes, it adapts, it finds another pathway. This fundamentally draws on the idea that we are complex adaptive systems. And the fascinating part is that this software seems to be upgraded by life experience. Epidemiological studies show that people with higher educational attainment, complex occupational histories, or highly engaging leisure activities have a significantly lower risk of developing clinical dementia, despite harboring the same underlying pathology. Their brains essentially route around the damage to optimize performance. How clever is that? So, reading books, solving problems, learning new skills, doing intellectually demanding work, and engaging in rich social and leisure activities may all help build cognitive reserve, which is excellent news for us philosophers who've just spent centuries making life unnecessarily complicated and can now describe it as preventative medicine. Now, let's put on our philosopher's hats and return to our great debate. Does cognitive reserve actually exist? Let's start in the red corner with scientific realism. The realists take successful scientific theories literally. Because the theory of cognitive reserve is highly successful, why? Well, because it helps predict why some people stave off clinical dementia longer than others. Well, the realists will argue that cognitive reserve must be an ontologically real feature of the brain. It is there. To the realist, cognitive reserve is not merely a metaphor, it refers to a genuine physical efficiency in neural networks, or perhaps to a specific measurable pattern of brain activation detectable through tools like fMRI. Using the no miracles argument, the realist says if cognitive reserve did not really exist, it would just be a miracle that the theory predicts patient outcomes so well. And philosophers are generally suspicious of miracles, as I said in the last video, unless they happen in peer-reviewed journals. But in the blue corner, the scientific anti-realism raises a big eyebrow. They look at cognitive reserve and say, well, hold on, this sounds suspiciously like a very convenient fiction. An instrumentalist might argue that you can't put cognitive reserve in a petri dish. You can't point to it under a microscope and say, there it is, just next to the hippocampus, looking smug. On this view, cognitive reserve is just a useful calculating tool, a placeholder term we use to mathematically describe why some people don't get sick quite as quickly as others. Alternatively, a constructivist empiricist will say that the theory is empirically adequate. It predicts the observable data, that memory test results, rates of dementia, differences in clinical outcomes, all that kind of stuff. But they'll argue we should remain agnostic about whether some hidden reserve network actually exists behind the scenes. Maybe cognitive reserve isn't a real thing in the brain at all. Maybe it's just today's version of phlogiston, a useful theoretical idea that helps organize the evidence for a while, but is eventually discarded and replaced by something better. So, what do you think? Is cognitive reserve a real, tangible property of the brain's hidden networks? Or is it just a highly effective label we've slammed onto a medical anomaly so that our data makes sense and everyone can go home feeling a little less confused? I'd like you to think about how you would classify cognitive reserve and state your view in the comments below. Are you a realist or an anti-realist when it comes to the brain's software? Thanks for listening. Please like and subscribe, and I'll see you on the next one.